Okay, let's begin by reviewing the previous assignment, LP6. So question number 1, something is a result of some cause that gradually affects, right? Gradually affects. I think gradually here is the key word. Recycling means this, right? And defect is irrelevant. Answer choice here. And process shift is also not a answer choice. These are all irrelevant because this is asking a pattern. So the only thing that can describe a pattern is A and B. Therefore, here B qualifies for the answer. And a process is said to be out of control when a process can be considered as out of control when again, this is irrelevant, a common cause are present. Okay, let's leave it for now. The process is not capable of meeting specification. Okay, the process capability study should no longer be an issue when we try to analyze the control chart. Okay, so there should be already enough study has been done to determine then whether the current process is capable of meeting the specification. Therefore, this is not a applicable answer choice. Special cause are present. So it's either B or D, but if you look at the process capability, the overall capability of the process, or the process characteristics, so we are saying the processes are out of control only when we spot something that has very little chance to occur. Okay, but anything within these control limits are considered as a common variations. These are something you should expect out of this process, but only when something falls outside or some weird, very unlikely patterns occur, then we can say system is out of control. Therefore, the answer choice, a process is said to be out of control when a special cause are present. Okay, number 3, and something characterizes the presence or absence of nonconformance in unit of work. It means presence or absence of nonconformances in unit of work. Therefore, the attribute measurement uses 0 and 1 to indicate whether nonconformances exist or not. Number 4, an alternative to using the R chart is S chart. Okay, so the rule to use R chart is when your sample size is between 1 and 10, right? And when your sample size is larger than or equal to 10, you start to use S chart as another alternative. The collecting data is usually easier than collecting this type of data because assessment can usually be done more quickly by simple inspection or count. Okay, so that indicates the number 4. Attribute is usually easier to detect just by looking at it. Okay, therefore, attribute data is easier to collect than the variable data, where the variable data you need to be accurate. And you have to use special equipment to measure the diameter or size of the defect down to 1/10 of a millimeter or even greater precision. The variable data are continuous. Okay, variable data are continuous because usually variable data are things like weight, right, length or temperature, time. So by saying continuous, it could be any data within given range, right? It could be any data. Let's say it's 7, it could be 10. Say if you're looking for weight, the weight can be actually any random value within certain range. Okay, this is also the reason why we are asking probability of a range rather than a specific probability when we talk about the continuous distribution. Okay, in continuous distribution, asking the probability of a specific point is actually meaningless. Okay, if you studied calculus a little bit, this will make sense to you. Question number 7. Which of the following is not one of the basic application of control chart? So what is not the basic application of control chart? So remember, control chart usually look like this. Here's the central line, upper control limit, and lower control limit. Okay? To establish a state of statistical control. Yes, we're controlling the process based on the statistical theories. And to calculate the average range, I'm not certain about this. To determine the process capability, I'm not very certain about this, but sometimes you can use that, okay? Although I did not explain that to you, that we can use this formula to estimate process standard deviation, which you will need to calculate the process capability. Therefore, C can be done, right? C can be done to monitor a process to identify special cause of variation. This is exactly what we're trying to achieve in here. So A, B, C, A, C, D is, you cannot root them out. Therefore, only thing remaining is a B. If you inspect further to calculate average range, in order to calculate average range, you do max minus mean. You don't need to rely on the control chart, right? So therefore, B is an answer choice in here. So which of the following, number 8, which of the following is not an indication of out of control process? So for this, you need to follow those rules, right? You need to follow those rules that I have explained earlier in the slides. So if you review the answer choice one by one, the first one says 5 consecutive points fall on one side of the line. If you refer here, this is talking about something like this pattern, okay? And let's leave it for now. 4 of 5 consecutive points fall within outer 2/3 region between the center line, one of the control limits. And for choice C, 2 of 3 consecutive points fall in the outer 1/3 range between the center line and one of the control limits. A single point falls above the upper control limit. If you refer to the slides I have prepared for you, that A is not an indication. You have to have, I think you have to have a 9 falling one side of the center line to be able to consider that as an out of control process. Okay. Number 8, the statistical process control relies on let's take a look. It relies on the control chart. Okay, process capability studies. This is studying process characteristics, process peak, and those kind of things. Overall, the process capability studies the capability of your process. Metrology is a science of dealing with the measurement accuracy, okay? And there's nothing to do with the statistical process control. And dashboard is just a way of displaying the information. Therefore, control chart is clearly the answer choice in here. What is being used to monitor the centering of the process? So remember, we are using our bar chart, and we're using the R chart to control the variation. We're using the X bar chart to study the control of the process center. Okay, we used 2 charts to control both aspects of the process. One is the variation, one is the center. Okay, because if you look at the normal distribution, there are actually 2 parameters for you to study. Okay, so you need to control one to be able to have a meaningful discussion on this one. Okay, if you're trying to discuss both of them, it's going to be not possible. Okay, so one must be controlled first, and then you'll be able to discuss about the other one. So that is another thing we have discussed in regression. It's a similar concept called with all other conditions remaining the same. Okay, that is the key idea here. So we used X bar chart to monitor the center of the process. Given that R chart doesn't show that the process variation is out of control. Okay. Number 11 to number 12 rely on the data set. So I'm just going to demonstrate by looking at the Excel. So if you look at this data, a lot of you made a mistake in identifying the K and N here. So K is the total number of samples here. So totally we have 30 samples here. And in terms of N, within each sample, we have 6 observations. Okay, so your sample size here is 6. In addition to that, we need it's A2, D3 and D4 to calculate relevant control limits. So let's first calculate R bar and UCL of R, LCL of R, and let's calculate R bar, X bar, and the UCL of X bar, and lower control limit of X. Okay, so I'm going to calculate range first, and then average. Some of you calculated range down below, and like this, and that is very mindless mistake you have made. Okay, I think initially I didn't know why a lot of you gave me a different answer, but later I realized that you may be calculating range column-wise instead of row-wise. Okay, please be mindful whenever you solve the quantitative problem. Okay, so sometimes your data is arranged differently. So here, this is a max, mean, okay, so what is going on? Take a look. Max, mean, it's H2. So I reviewed my formula and corrected it. Okay, so it's nothing fancy. You get the maximum, you get the minimum, you calculate the difference. Okay, and then we do it for all of them. For average, it's nothing but this. Okay, then we double click. I also got the average here. Let's calculate the average of averages. This is average for all the ranges here. And here is the average of all the averages. Good. And we have R bar equal to this, and X bar equal to this, X bar, I'm sorry. So in order to calculate A2 and those kind of thing, you need to open up the file I gave you. But let me pull this out quickly. Okay, since our sample size is 6, right? You want to looking at this particular row in here. So A2 for sample size 6 is put here, and D3 is 0, right? Anything less than 7 is 0. 004. Okay, I think you're almost done here. So for this, for upper control limit for the R bar is R bar multiply D4. For the lower, it's going to be this guy multiply with 0. Okay, and for the upper control limit of X bar, it's plus, sorry, it's not 3, it's going to be A2 multiply with R bar, and the same minus R bar multiply A2. Okay, so the this is what you are getting out of the last component. Oops, somebody was sending me an email. Okay, so yep, this concludes this review.